us begin. So it is week 10, day 2. And I was thinking about having you guys do a blend space and a animation blueprint, and I still might. Let me just show you what that looks like, so you can see kind of what a more proper animation looks like. Because these animations are just looping, right? Like when we that one's not looping, obviously, but you know, we just attached a animation to a skeletal mesh, and it just plays over and over again. So not very interesting. What we want is a intelligent animation. So if we're crouched, if we're jumping, if we're strafing, running forwards, walking slowly, then it will do different things. And so this does exist, and if we were to put out this guy here from the animation starter pack, hit N to snap him to the ground. All right, he is on the ground. Cool. And you can see right now he's just idling, right? It's because I have not attached a controller to him. This is a pawn. A pawn is something that can be moved by a controller, and right now it is not moving, and so it's just playing the idle animation. But I can show you what it would do if I attach this to the player. So if we come over into the animation blueprint, so this guy here, you can see his animation isn't a loop like these guys. These guys, they just are using an animation asset, and it just plays, in this case, death, and ends. Boring. This guy here, as he moves around, he is going to be animating in different ways. And so let's take a look at that blueprint that is set up for him. And then you guys can tell me if you want to set up one of these things as your next homework assignment. They're not too bad. So this is something called a animation blueprint. And so an animation blueprint is, it looks like, you know, the other node-based editors we've used. So far we've used the blueprints for code, and we've used the material editor, which is also a node-based editing system. This is also a node-based editing system. This is not a blueprint for code. This, you can see the output is a pose. And so you can start off by just, if you wanted, you could just put a, like a really basic pose there, like, I don't know, idle or whatever, and it would just idle the whole time. And it would effectively be the same thing as your, these guys over here that are just, you know, these guys over here, they're just playing an animation. But an animation blueprint is interesting because you can actually have different inputs, and then based on the inputs of the blueprint, it feeds into this thing here called a blend space. And the blend space not only chooses between different animations, but actually can average them together and blend them together, which looks really nice. So there's crouch walk and then jog. Yeah. So if I double click on jog here, you can see that there are two different inputs. There is direction that the person's moving, and that's relative to the way they're looking. And so that's if you're strafing or not. And then the other one is how fast you're going. And so you can see that if I speed up, the guy runs faster. Okay. And then if I strafe one way, if I strafe at 90 degrees, if I strafe, it's running backwards now. Let's see. Run backwards. Run one way. Yeah. So basically, based on the input of the speed and the direction, it'll choose between these different animations here. So what they do is they just put onto here points. Did it crash? Oh no, it just loaded the other one that I've been loading for like 10 minutes now. So we'll go back where I was before there, and you can see that if you hold down shift, it'll just preview for you what it looks like with different inputs of speed and direction. looks like they don't really have an idle animation here. It's all jogging, which is why you don't see it really move slower very much. Animations, as always, are tied to skeletons. And so really what this is doing is just it's handling running backwards versus strafing. Right? And what you can do is you can drag things out here. So if we have an idle animation, I can put that out here, let's say. And then you can see when it's near that, it idles. And then if you increase the speed, the running speed will increase. Okay. So I think, honestly, when the speed is at 0, it should probably just be playing the idle animation. So I could, let's see, right click. Put that one on there. And then it'll interpolate, it'll linearly interpolate from idle, that's speed 0, to running forward, like that. And if I strafe at 90 degrees, if I strafe at 90 degrees, it works, but if I slow down, we'll see I have that node on there that has the jog animation on it. So honestly, all of these down here should probably just be the idle animation. So just delete all of these down here. And now, when the speed is 0, it basically doesn't really do anything. I could actually put this out, all of these points. Like that. So you can drag different animations out there. And you can make it so that at different combinations of speed and things like that, it will play different animations. And so at full speed, it's running forwards, running to the right, running to the left, or running left backwards, I guess, which is kind of odd. Running backwards, because 180 degrees in either direction is backwards. Right? And then as you're running backwards, as you come to a stop, the animation stops playing. So you can run backwards at full speed, or you can run backwards at no speed. And so depending on these different combinations, you can see the person swivels, and it's blending between all these different animations here. Very classy. Very classy system. Okay. So if you guys want, you can do that as your next homework assignment. It's not too bad. The only trick is how do you get direction and how do you get speed into there? Well, I'm actually going to save this because I think this looks better than the default one. So these two things are the inputs to the blend space. Where did they come from? Well, they come from the event graph. And the event graph is, I wonder how hard this would be to code. The good news is you don't have to wonder, it's done for you. And so I don't know exactly how to make this a homework assignment because it's already done. Oh, do you mean to code this thing? It's just it's a bunch of lerps, really. You know, so given an input direction and an input speed, it's just going to linear interpolate between them, right? And so it knows where this animation wants the foot to be, and it knows where this animation wants the foot to be, and so you just average between them, right? It's not too bad, I don't think. You just have to make sure the animations are synced up, you know, so their feet are moving in the same direction. So they'll blend between them nicely. Yeah, not too bad to code this, I don't think. So, where do these inputs come from? They come from an actual blueprint. And the blueprint, at the end of the day, is going to set a couple different variables. First is called enable jump. That determines if you're jumping right now. Then there is a key for crouched. Get pawn owner. If the crouch down button is set, that's actually a probably public variable on the blueprint class for that. If that variable is set, then it sets this variable to be true. If the jump button is hit, then and you can jump, then it'll play the jump animation. But let's see here. Still haven't got my voice quite back yet from Sea Shanty Night. I pushed my voice too hard. Actually, it's probably the death metal singing that did it. All right. So if we're the player, then it does this. Otherwise, it does this. It sets the jump button. Okay, so movement and jump. So, where is direction? Speed. Set direction. There it is. Okay. So, what happens is blueprint update animation takes place every frame. So every time this thing is trying to animate, it's going to it's going to do two things. It's going to grab the velocity of it, of the owner of it, of the owner of the blueprint, which is the mannequin. It's going to grab the velocity and it's going to grab the direction. Remember how to get speed? You guys remember that? How to get speed out of a vector? Like if you're running at 100 to the east, your speed is 100. You guys remember that? Velocity is speed in a direction. Not divided by time. It's just the magnitude of the velocity vector is your speed. And so to get the speed at, if you have the velocity, to get the speed, you just take the vector length. So if you're traveling 100 miles an hour east and 100 miles an hour north, then your actual speed is 1.41 times 100, 141 miles an hour northeast. Okay. A little bit of trigonometry. Okay. But that's pretty easy. So you just get the length of the vector, of the velocity vector. And then it sets it. And so every tick, it's going to see how fast the mannequin is moving. And it just saves that into a variable here. And then every tick, it reads that variable out. And then the direction works the same way. There's a node called calculate direction. And so based on the velocity and the rotation, it can tell which way you're moving in relation to your velocity. So are you looking in the same direction you're moving, right? Or you could be moving at 90 degrees to the direction you're looking. That's a strafe, right? So that's vector math. Good news is there's a node for it. And so that just gives you a direction, which is a angle from 0 to 360. 0 and 360 are both, you're looking in the direction you're running. Otherwise it will, oh look, it's a dot product. Otherwise it'll give you an angle of, which direction you're strafing in, right? So if you're running at a 90 degree angle to the direction you're looking, it'll return 90 degrees. Sets that variable, and then the blend space inputs direction and speed, and picks between the different animations, right? So strafing one way, strafing the other way. Yep. And that is that. That's how you do. And then this whole thing here is in what's called an animation blueprint. The animation blueprint can be found in the animation starter pack if you want to look at it. Some of the other stuff is actually found in the character blueprint. So this is meant to be possessed by a controller. So a controller is supposed to take this over, and then it'll read like the mouse, and it'll read the crouch button, which is not set, I don't think. I don't think the crouch button is set. Warning, yeah. So we need to make a thing for that. Project settings, input, action mappings. We need to make a crouch button. Crouch, and the crouch button will just be controlled by itself, I guess. Or if you hit C. Okay. So, good, that works now. And so if you hit Control by itself or C, it will set crouch button down and it'll pick that animation to play. If you release it, it'll clear it. And then if you hit the jump button, then it will set jump button down and does all this stuff. The upshot is it will have you jump it. It also it'll set this variable called jump button down or jump button cleared, and it can read that in the animation blueprint to pick a different animation to play. So, do you guys want to make one of those for your next assignment, or do you want to do a heads-up display, or both? What do you guys feel? A heads-up display, displaying like words and text in 2D on top of the screen. Let's see if I can find a picture of a heads-up display. Not useful. Like one of these things, right? All these kinds of decorations that float on top of the world. Is that some sort of Overwatch ripoff? So it's got, you know, your different command abilities down here, your health. I don't know. That's all part of the heads-up display. Okay. Paladins. Okay. Did anyone play Paladins? How is it? It's a heads-up display like the first-person shooter text you see on the ground. Yeah. Worse than Overwatch, but interesting characters. Okay. You killed Genghis Khan. TF2 exists. Yeah. All right. So, what do you guys feel like? You guys want to recreate a actual animation, or do you feel like moving on to heads-up displays? $50-50. Okay, we can do both if you want. All right. All right, no firm commitments from anyone here. All right. Okay. Wait till tomorrow. I'm gonna go through that process with my ICE 50B people tomorrow, and we'll see how it is. So wait for tomorrow for your homework assignment, I guess. They're both useful, and so we're kind of coming to the end of our animation section. We still need to do AI and heads-up displays, and after that, you guys should be pretty good. Heads-up displays will also show you how to like put up a start menu. You know, like when you hit escape and you know the options and new game and all that stuff up here. Yeah, we can learn that today. Yep. Health bar. Yeah. Okay. So let me move this out of the way and hit play here. RTX on. Look at that. It's all shimmering. Look at that. Not screen space reflection. Look at that. There's ray trace reflections. I was hoping this one had... Oh, there we go. There we go. See that? Ammo count. Okay. Alright, so that's why I wanted to pull that up so you can see what it looked like, and then I'll walk you through it. Let's see. Have bullets left. Draw text, draw texture. Yeah. Okay. Alright. Alright. Okay, so let's say that you wanted to display, let's say you want to do health. Like that's pretty useful, right? Having health. You can have health on enemies and on snowmen and on the player and stuff like that. It seems useful, right? So let's edit our first person character, which is in the first person blueprints. And at some point I want to add a body to him, you know, so all right, so in your first person BP folder, inside of the blueprints folder, you will see two really relevant things. Well, three really relevant things. First is the first person game mode, and that one will set the HUD class. So the HUD class is what HUD stands for, Housing and Urban Development, right? It's what, wait, no, heads up display. So HUD matches. No, sorry. Heads-up displays are for. I'm kidding. Heads-up displays were originally used in airplanes, right? So pilots wouldn't have to look down at the screen and then look back up and like, oh, there's a tree there, you know. It's so heads-up displays display information on the screen in front of you, and they were adapted from flight sim games into first-person shooters and things like that. So the heads-up display by default is this one, and this setting is set in first-person game mode. And if it's set in first-person game mode, first-person HUD, you click at the little magnifying glass there, it'll select it here. And so any edits you make to this will just automatically work. Okay? So don't draw if using the VR headset. Cool. All right. And so if you double-click on that heads-up display, you'll see there is a HUD already. There's already a heads-up display, and that heads-up display is the crosshair. So when you're looking around in the game, you can see there is a little red crosshair there, right? See that? Okay. So that is the entire heads-up display. What kinds of things can you draw on a heads-up display? There's two giant categories of answers to that. The first is what I'm going to show you guys today, and the second is the correct way of doing it, which I'm not going to show you today. So, but I always like to show the simplest things first so that you guys can get started. So if you guys can all open up your first-person HUD and take a look at it. I don't have a VR headset, so I'm just going to actually just knock out that whole thing there. Good. And crosshairs are HUDs. It's a HUD is a 2D image that is displayed on top of the 3D world. It does not interact with the 3D world at all. Even if you have a branch coming through the camera, the crosshair will still display on top of it. It does not interact with the 3D world at all. Some people try doing things like having, like in space sims, like you're actually in a cockpit and the cockpit is in 3D. The trouble with that is that if anything draws between you and the instrument panel, you can't see your controls anymore, right? Does HUD include GPS map of world map line data on GTA? Yeah, like your mini map, that would be part of the HUD. Sure, yeah. And you would probably do that using draw texture. So draw texture, what is a texture? A picture, right? And so can you draw part of the picture? Yeah. Remember how we talked about UV coordinates? UV coordinates allow you to slide a picture around on top of the surface. So you could do a mini map really easily with this thing right here. So rather than using the first-person crosshair picture, you could get a world map and use the U and V coordinates to figure out, let's see, you get your position in the world and figure out where you are in the world and how that maps to the mini map, and then it would just basically slide the picture around to wherever you are. So as you walk around, the picture would just slide with you. And it's really easy to do. The hardest thing is actually just knowing how big the world is, you know, like how much of the world does the map correspond to. You got to have that hard-coded somewhere maybe, and just figure that as you walk around, just making sure it maps exactly to the world. And then of course you have to make sure your map gets updated. As if the mini map doesn't update when the map makers move buildings around, then you know that breaks too. So maybe you do something clever and you automatically take a picture of the world or something like that. Like when they finish making the map, it snaps a photo from, you know, a distance above and turns that into a 2D texture and exports the size of the world, and then all that gets fed in. You can make a really nice one, but at the basic level, it's really easy. Let me show you. So rather than first-person crosshair, I'm gonna draw. Oop, Unreal. Yeah. All right, we'll do that. Okay. And so this is how many pixels wide and how many pixels tall. Let me zoom in so you guys can see that on Discord or on YouTube. So when you draw a texture, this thing's going to get called every tick, by the way. So every time it redraws the screen, it's going to redraw the HUD. Okay. And so right now, what it's doing, it's taking the size of the screen wide, size of the screen high. This is going to be in pixels. So every because you can resize the screen, right? Every frame, it's going to figure out how big the screen is in pixels, rows and columns. Divided by 2, that's the center of the screen. It then moves it up 20 pixels up in the Y direction, or down. down in the Y direction. Positive 20 is down. 0, 0 is the top left of the screen, and as Y increases, it goes down. So this is going to move the crosshair down 20 pixels so that it matches where the gun's shooting, and because the gun's a little bit below the center of the screen. And then that's the address that it draws the picture at. And so then that's it. So that's the place on the screen, the 2D. That's the 2D coordinate, X and Y, where it's going to draw on the screen. The top left corner of the image. It's going to attach to myself. This is the picture it's going to draw. So I'm changing it from drawing a transparent red X to the UE4 logo. So you'll see what that looks like in a second. This is how many pixels wide, how many pixels tall. I'm going to change that to 64 by 64 to make it a little bit bigger so you can see it. And then U and V are used, like I said, you can move which part of the image is being drawn around, right? So you can slide it around if you want to do a mini map or something like that. And then you can scale it up or down as well. So you can zoom in and zoom out. If you have the mini map, you hit comma, it zooms out. You hit period, hit period, it zooms in, right? And then you can colorize it if you want as well. So this is going to add a no color to it, really. But if we wanted, we can make it red or whatever. So if I compile this and save it and run it, you guys will see I've got a brand new crosshair. And the crosshair is the UE4 logo. Can you guys see that on Discord? Is that coming through? All right. So that's it. That's all it takes to draw a picture on the screen. And so if you want to have like a fancy health bar thing with all the decorations, you get an artist, not me, you get an artist to make all those cool, decorations, and you use draw texture in it, you spit it on the screen. And you can and should make transparent textures. So transparent doesn't mean white. Transparent actually means no color whatsoever. So when you look at a transparent texture, if there's no pixels there at all, it will draw. That's not very useful. You'll see the checkerboard pattern. The checkerboard pattern means there's no art there at all. So it's got red and then no background. Okay? And that's done using something called an alpha channel. So for every pixel, there is red, there's green, there's blue, and there's alpha. And we typically ignore alpha because normally we don't care. Alpha means transparent, and it's used in things like, this thing here in front of me, right? So if it's translucent, it might have an alpha of like 0.5 or 0.3 or 0.7, depending on how transparent you want it. These pixels are set to be fully transparent, and so it's red pixels that are opaque or partially opaque. It looks like there's a little bit of blending going on there. And so the alpha values on the edges here are in between 0 and 1. And then all these background pixels are just set to transparent. And so it just draws the crosshair over the screen without a white background on it, which is a problem that a lot of new computer science people have. They just have a white background, and so you have the crosshair and white behind it instead of it being see-through like it should be. So like here, this is not transparent. So you see how you can't see through the picture? It's because none of it is set to be transparent. Okay. So whenever you do a thing with a HUD, you want to set any parts you're not drawing to be transparent. That way you can just kind of blit the health bar, the cool looking health bars, or if it's Diablo 2, they've got these like globes holding your red and your blue. So if you guys have ever played any of the Diablo games or any action RPGs, you should be familiar with this sort of interface where you've got a health bar and you got a mana bar. In this case, it is a red ball holding your health liquid, and this is a mana ball holding a blue liquid, which is currently empty because he's, I don't know, maybe playing Barbarian or something, I don't know. And then, but you see how they got these gargoyles and an angel here. All that's just a texture. It's just a picture. And so all you do is you call draw texture, and probably this whole frame, like all this stuff, like with the XP bar, all that stuff is probably just drawn. And then then I'm going to show you guys in a bit how to do like the health bar bit of it. Okay. Or if you've ever seen Street Fighter, where's Prado? Not here. There we go. So you can see all this stuff. You know, the portrait of Ryu and Chun-Li. All this stuff is probably just one. Anything that doesn't change is probably just one picture that has transparent elements to it, and then the health bar will be drawn on top of it. Okay. You guys understand the theory of this? And does UE4 do that for us? Is there a way to determine the resolution of the player's display? Yeah, I just showed you. Right there. That's how many pixels wide it is. That's how many pixels tall it is. The health bar are not HUDs. The health bar is part of the HUD, but it's not a picture. Well, it could be, I guess, but usually I'll show you in a second how to do health bars. The pixels on a 46-inch 4K display are the same size as the pixels on a 23-inch 1080p display, right? Yeah, this is the resolution. It's not. You really don't know how big the display is. What matters is the number of pixels you have. So all you really know is the resolution. It could be on a 4-inch 4K display, maybe. You don't know. Okay. It's up to the person to. Well, you can do something called UE scaling, and so UE scaling, you could feed in something like this. Make a new variable, call it UE scale. UE scaling, and you are going to be a flute. You're going to be public, so we can edit it from elsewhere. And in order to get this to appear, we have to compile it, save it. So I made a new variable called UE scaling. It will default to 1. And then let's see if we crack that out here. Git. So we plug that in there. And if we were to say change that to 2, and we can do this through blueprints. Or maybe the user has a configuration file that will change the UE scaling. No, shoot, that quadrupled it. There we go. Yeah, so that you see how it's zoomed in. So if let's see, what do I have to do? I have to multiply 1 over. Promote to variable. Picture size. I'm going to make that a variable. So picture size. Get picture size times UE scaling inverse. This is something that is near and dear to my heart because I have a 4K monitor and break. So many games don't scale properly. Alright, so if we do that, then that should be the screen height and screen width. Okay. So then you can configure the thing. It's bigger now, but it's not centered properly. Broke something, but yeah, that's the general idea. Is you 1 divided by that, so 0.25. That should be multiplied by 4, right? And then height. Normalized UV distance. It should be. Yeah. That's how this goes. Upper quarter of it. Let's see here. Does it depend on aspect ratio? You can figure out what the aspect ratio is just from the thing. All right. There it is. Yeah, you can divide the x by the y and get the aspect ratio from that. There we go. All right. Yeah, so you can basically what you want to do is have a variable called UE scaling that the user can set between some 0.1 and 10 maybe, I don't know. Span, I think your caps lock is held down. Yeah, so basically, you can see though that the thing is growing this way because I'm not moving the screen coordinate either. The location I'm drawing it at is always the top left corner of it, so I should move it left and up so it gets centered on the center of the screen. So if I come back in here as well, so I need to adjust the place that it draws at. So let's get picture size divided by 2. Picture size divided by 2. So that'll tell me how many pixels is half the image. So I need to move it left that many and up that many. So I'm going to simply move it left that much. Divided by 2. U minus float. U. Goes into x and u minus float. It's only work for a square image, obviously. Goes into there, and so yeah, really any picture you can draw on the screen. There's nothing really special about the UE4 logo. I just picked it because it was there. So you see how it's centered on. You see how it's centered on the screen now.
Why are there so many people?
Huh?
Why are those people trying to shoot at you?
Nope, they don't do anything. It's just playing an animation over and over again. Okay. So you see the corners of this are transparent, right? Yeah. Lost the video.
Dr. Cherry is weird.
Guard Cherry. Yeah, this is before I showed them how to properly do animations or timelines, And so the thing is just randomly moving up and down. So.
I mean, that door, the automatic door you put out there is kind of annoying.
Kind of annoying.
Because you have to wait for it to go down, then you can go off it. Or you can just go around the door.
You could adjust the timeline so it goes faster or whatever. Okay, so you can use this to draw any part of the screen. Like if I wanted, I could just constant. What is it? Picture size. What are you doing here? Break. Link. There. X0. And we'll break the link here. So this will draw on the top left corner of the screen. And so if you wanted to have like you're making a Street Fighter interface, you would probably just have an image that would cover the entire screen, and you draw it at just 0, 0, which is the top left corner, And when you do that, you'll see the UE4 logo appears in the top left corner of the screen now. Right? And so you just have a picture that covers the entire screen that has the health bars and all that other the non-moving stuff. You just use draw texture for that. Okay.
You see that lavender right there?
Or if you wanted to do like a dialogue system, you can make it so that when you walk up to talk to somebody, a picture is displayed on the screen. Okay. So for example, you can make it when you walk up to the snowman, it draws a picture of Olaf, right? You want to do that, Ada? You want to be able to talk to the snowman? No. No? Huh? What about my students? You guys want to be able to talk to Olaf?
Do you want to decapitate a snowman? Do you want to decapitate a snowman?
Okay. Do you want to decapitate a snowman? All right. Olaf. Don't sue me, Disney, if you're watching this. Okay. So, sure, that looks friendly. All right. There we go.
His head looks like it's going to snap off.
So I'm going to save this image. It's a WebP format. Save image. JPEG, that's better. All right. Okay, so let's go ahead and import this into our content browser. So we go into Bill, and I'm just going to click on here somewhere, and we are going to import into this directory from the desktop Olaf. See, Olaf has appeared. Okay, what do you think, Ada? I hate JPEGs due to the quality, yeah, but I don't know if Unreal Engine supports WebP format, so I didn't use that one. Yeah. What's up? Yes. Yeah, I could convert it, but we're in class right now, so. Okay. I just want to have something simple, so when we walk up to the snowman, I want it to display Olaf and have him, I don't know, say something. So, what do I call this guy? Snowman? Frosty Talks? Yeah. The non-copyrighted version of it. All right, so Frosty Talks, event tick. All right, let me just show you first of all how to display him on the screen. You use draw texture and you pick Olaf, and that's how you draw Olaf on the screen. Pretty easy, right? So inside of your HUD, there's event receive draw HUD that runs every frame. Draw texture will just put a picture up on the screen, so it's pretty easy, pretty straightforward. You can draw more than one if you want. Like I could have the crosshair on there or whatever, but yeah, that works. There you go. There's Olaf. It's a little bit distorted, so we can change the size of it. Picture size needs to be 2 things now. We need picture size X and picture size Y. Compile, save. So that is X is the width, picture size Y is the height. I'm not using any of this stuff right now, so just get rid of it. Okay, so, and then we can promote these to variables, I guess. Promote to variable, and this will be called offset X, and promote to variable. Offset offset Y. So that'll control where Olaf appears on the screen. So if we wanted, we can have it appear on a random. Random. This will look terrible, but it'll be funny. So we're going to get a random location from 0 to the right side of the screen. That's where it'll appear. And so literally every tick it'll appear on a different location on the screen. And then the picture size, I don't know, it'd be like 512. Okay, we'll start off just by doing this. And Olaf has vanished. I thought I saw him a second ago. Yeah. This is a dumb idea anyway. So we'll just leave it at 0, 0. And try that. Yeah. What happened to Olaf? Oh. Picture size 0 is set to 0, that's why. Okay. There we go. So there's Olaf, and if we wanted to do that stupid random thing again, I guess we can do that just to horrify you guys with bad coding. Compile, save, play. And you can see there is Olaf flashing around the screen, causing people to get annoyed at you. Yeah, so anyway, rather than using that, we'll just use offset X and offset Y. And we made these public variables so that we can have like the player control them and things like that. All right. So do you guys understand draw texture? Draw texture draws a picture on the screen. If we wanted, there's other things we can print on the screen. There is draw rectangle, which we can use for a health bar. We'll do that before we get to making Olaf appear when you come close to him. So let's draw a rectangle on the screen at 200 to the right, 200 to the right, 400 down. We're going to make a rectangle that is 222 pixels wide and 100 pixels tall, and this thing is going to be bright red. Okay. And so bright red. And so what you can do with draw rectangle is scale it. You can actually make the width proportional to the health of the player. And so you can do things like get player, control from ID. So you can get player 0 and you can get their health out of that. We don't have health set yet though, so I'm not gonna do that quite yet. But basically you can make the width of this rectangle you draw be proportional to what percentage of health they have. And so you can make it as they take damage, the red rectangle gets smaller and smaller. So there you go. So we got a rectangle on the screen. Okay. Easy. Let's make it a little narrower. It's a little lame looking right now. Okay. And the other thing you do is draw text. Okay. So we will print the screen, hello world, again in bright red. Let's make it bright purple. Why not? Let's be different. At location x divided by 2. Y divided by 2. So this will print in the middle of the screen, hello world. We don't have any fonts. Let's see how that'll work. Font. There we go. So you can see in very small font, we say hello world in the center of the screen. And we can scale that up based on the UE scale parameter. So if we want it 4 times UE scale, again, this should be set by the user, so the user can control how much scaling they want. For people that have poor eyesight, it's really important to allow them to make the text bigger. So there we go. With 4 times UE scaling, you can see Hello World prints on top of the screen. Now remember, all of this stuff that I'm showing you today is the basic version of doing HUDs. There is a better way of doing HUDs using widgets and things like that, and maybe we'll talk about that next time. But these are the 3 basic tools. Okay? Could you make the rectangle get smaller with every 100 ticks of the clock? Sure, why not? So ticks or seconds, which one do you want to do? Because if it's ticks, then the higher the frame rate, the faster the rectangle will vanish. Or you just make it ticks if you want. That's fine too. All right, seconds. It'll be an oxygen meter. Sure. Okay. If we're going to do an oxygen meter, can't be red. Oxygen meters can't be red. That's just a rule. You are the wrong one. I don't care about you anymore. Okay. So if it's going to be an oxygen meter, it needs to be blue, of course. Make it a nice blue color. And let's see here. What are we going to do? We can make a variable called last breath that is public. Any public variable can be set by another blueprint. Okay? So anytime there is a public variable like this, another blueprint can set it. And so, for example, the last time you were above water, it'll set last breath, and then it'll shrink this thing as the time duration from the last time you breathed till now happens. So how are we going to do this? I wonder if begin play. Does begin play work with this? Let's find out. Begin play. Does this work with a HUD? That's a good question. If it does, we'll be happy. So we are going to set last breath. So when the game begins, get the current time. Get time in seconds. So that gets the time. So when the game begins, hopefully this will work. I don't know if it works on HUDs or not. It'll record the time, and then we will get the time every time since our last breath. And let's see, how do we want to do this? We need to do algebra here. All right, so we want the width to be 200 minus. How long do you want it to be until you suffocate? How long do you want them to hold breath for? How many seconds? What do you guys think? We get the current time of day here. 8 seconds, 4 seconds. Let's do 8 seconds. 4 seconds is really and you're dead. Although in a lot of video games, people have very unrealistically short breathing. It's kind of like in Valheim. You're this mighty Viking warrior, and you can swim about 10 strokes. You're like, oh! And you die. It's like, there's an island like 100 feet away. It's not even far. You can't make it without dying, at least at the beginning of the game. Okay, so yeah, 8 seconds is fine. Okay, so we will get last breath. Okay, so get the current time. Okay, so we're going to get the current time. Let's say it's 10 seconds, and the last breath was at 5 seconds. That means, okay, so we're going to do a minus, flip minus float. And so this is going to be how many seconds it has been since the last breath. And we want to shrink this, so it's going to be 200 minus, we need to scale this, let's see, divided by 8 is the max breath. Divided by 8, and so that'll give you a number from 0 to 1, or we could lerp that. Okay, that'll give us the number from 0 to 1, but we need to clamp it. So it can't go over 1 or negative. Let's see. Yeah. Clamp. Minimum value 0, maximum value of 1. Good. Okay, so this is going to give us the number from 0 to 1. 0 meaning we just took our last breath. 1 meaning we're out of air. And we are... that's backwards. I kind of want it to go the other way. So it'll make the math easier. So let me rewire these things. No, that's going to be a negative. Damn. All right. Let's see. 1 minus. 1 minus. We'll do it that way. It'll be easier. Okay, so this will... okay, there's a lot of algebra going on here, but basically the upshot of all this stuff is as it's been longer and longer since our last breath, it'll go from 1, meaning full oxygen, down to 0, meaning no oxygen. So all we're going to do is multiply this by 200, which is the... by 200, which is how far we want the rectangle to be. And then over time, the rectangle will shrink, or at least hopefully, with the amount of coffee I've had, the odds that this will work. Let's find out. There we go. Of course it worked. Why should I doubt myself? There you go. 8 seconds, and it clamps to 0. Boom. That's how we do. That's how we do. And so all you have to do is say, if you are not swimming... reset last breath, right? So let's see here. You probably get our physics. You probably get if we are swimming or not. We only got half an... let's see if we can figure out how to do this. So let's have it only appear when you're underwater, right? Run out of oxygen, play die animation. Yeah. Have the 2 arms go like this. Because we don't have a body. Right? Or we can do this. Here, even better. So stop running. If we'll do a branch. If this is at 0. So if we have hit 0 oxygen, then we will print you dead. How about that? So it's not going to print hello over the world because that's annoying. So there we go. Our oxygen's running out. No, I can breathe. Oh, no. Then it prints you dead. All right. So remember, we still haven't done a health system yet, but that's coming up. It's coming up soon. All right, so your 3 basic tools for basic HUDs are drawing a picture, drawing a rectangle, drawing text. There's also drawing a line, but who cares? You can draw a line if you want to. But there's a real way of doing it using widgets where you actually create a widget and you place it on the screen, and the value of the widget ties into a variable, and it's a lot nicer. But this way works for basic stuff. Okay, it's a good place to start anyway, so you kind of understand how HUDs work. Okay, so let's see if we can make it so it only does this if we are... Okay. Right. So every tick, get... Oh, how do we do this? Can we get if they're swimming? Is that... I don't think that's being set right now. Okay. Let's see if this works. So, if they're swimming. Okay. Cool. All right. So the physics volume that we set up for the pool should do this. So if they are swimming, then we will draw the rect. Okay, yeah, I think we can do this. Okay, if this works, if it's being set properly. I don't know if it is. So we'll do a branch. Oh man, this is turning into spaghetti code. I don't like spaghetti code. You get out of the way. You. All right. Let's not worry about an Olaf. That's what I want to do. Have it when you walk up, it displays Olaf, but whatever will not display Olaf currently. We're just going to do a branch and branch. Okay. And so if they are swimming, then it will draw the oxygen rectangle. Okay. If they're not swimming, then it will set last breath. So literally every tick, it will be, every tick they're not swimming, it's going to be recording, yeah, they can breathe. And then once they go underwater, it'll stop updating that and it'll instead draw the rectangle. So let's see how that goes. It worked right the first time, last time. Sure, will work right this time. Here we go. Open the door, thank you. All right, no, see how there's no Olaf now? I turn Olaf off. Move barrel, move. Okay, go in here. And there is the oxygen meter. Woohoo! No, don't swim up to the surface. Don't swim. No. Died. Yes, there we go. Okay. And then if we surface, just going to bypass the door this time. Okay. There's the oxygen meter going down, and if I make it out, the oxygen meter turns off. Cool. If I go back in, there we go. And I can, if you wanted to do it like a video game, you display a gasping sound every time you come up out of air. I've been underwater for 8 whole seconds. It's so annoying. Every video game, you surface. I almost died. I was underwater for 5 seconds. All right, so that good requests. Good requests, Bound. So yeah, so we can come back to this, I guess. But let's admire this for now. Okay. So what it's doing, it's getting player index 0, which is the player. Single player game, makes it easy. So it's getting if we're swimming or not. That's being set by that physics volume, which will set us to swim. Cool. And then if we are not swimming, then it just records the current time as the last time we breathed. If we go underwater, then it's going to difference the time that we last breathed from the current time, and use a little bit of algebra to give you a number from 0 to 1. 0 meaning there's no oxygen left, 1 meaning you have full oxygen left, and multiplies that by 200 pixels, and that is the width of the rectangle we draw. So it'll very smoothly go down to 0. Okay. And then if we ever hit 0, then it displays you dead on the screen. And in reality, you'd probably respawn the player or something like that as well. Okay. Lave, Rosenberg, Ramos, Dahlin, you understand? It's a little bit of... I would probably want to refactor this a little bit so that the algebra is a little easier to understand, but it works. It works. All the stuff we're doing in the HUD is to draw things in 2D on top of the camera. And our tools are pictures, rectangles, lines, texts, materials. Okay. All right. Okay. So let's have Olaf. Let's interact with another blueprint now. Okay. So maybe let's finally do now. Let's do Olaf. So let's have Olaf talk to the player. Okay. So how do we want to do this? So we could do a level blueprint. We can set it on the player. How do we want to do this? There's a lot of different ways you can do it. We have the HUD. Simply get the distance to Frosty every frame. It's a good way of doing this. I guess we'll create a variable on the player. Let's do that. Okay. So first person blueprints, first person character. And so this is the where the player lives, like the clicks and the mice and all that stuff. Jump and the mouse and all that stuff. So we can make a new variable in the player called near Frosty. We will make it public. Public means that Frosty will be able to read and write to it, and the HUD will be able to read. It's not going to write to it. It's going to read from it. Okay. So near Frosty will default to false, as you can see here. And then I don't think we even need to really do anything in the blueprint itself. I'm just making a variable on the player. And so basically the way I'm setting this up is that when you walk near Frosty itself, it's going to have an event trigger called overlap with player. And it's going to set that variable to be true on the player. And then when that gets set to be true, the HUD will pick it up. And it will get Frosty. Let's see. Cast to first person character. Hopefully that'll work. Put that down here. And move on. That should always work though. Okay, so we want to get. Let's see what I do. We can do this. We want to get Frosty, get near Frosty. Okay. So if get near Frosty is true, branch. So this is an easy way of connecting between blueprints. There's other ways of doing it too. You can have a variable that holds an actor, and then you can cast that actor to whatever thing you know it's going to be, and then grab variables and set public variables off of them. We talked a little bit about this before. We'll talk about it again. It's really important to get blueprints talking to each other, and it can be tricky sometimes. So here we are going to say, okay, so get first person character. So if we are near Frosty, we are going to draw Olaf. And if we are not near Frosty, we're not going to draw Olaf. Do you guys see it? So if the variable near Frosty is set to be true, then it's going to draw Olaf on the screen. And maybe we can have it print a text or something as well, like, hey, how you doing? Or play an audio or something. For now, we're just going to have Olaf appear in the top left corner of the screen if you're near Frosty. Maybe we should move it down a little bit. Offset X, offset Y. Maybe we will get the height of the screen and minus it by the picture size. So it'll appear on the bottom left corner of the screen. Like that. Yeah, I know. It's the downside of using blueprints. So what's happening here though is it's checking to see if the person is near Frosty. If the person is near Frosty, then it is going to draw Olaf. If he's not near Frosty, then it moves on to the rest. And after it draws Olaf, it moves on to the rest. So the only other thing we need to do is make Frosty Talk set that to be true. So every tick, let me just do this. So when the player enters that sphere, remember Frosty has a collision sphere, an invisible trigger, sphere trigger. When the person walks over it, we will get cast to first person character. So when the person walks over it, it'll only work on the person. We will set Frosty near to be true. So when the person, and it only works if you shoot a ball, this casting will fail and it won't do anything. So when the person walks next to Frosty, it will begin overlapping. It'll set near Frosty to be true. And then when they end overlap, cast to first person character. When they leave, then we will set near Frosty to be false. There. Okay. So Frosty has an overlap event when the player enters. It sets the Boolean to be true. When the player leaves, it's set to be false. And then the heads-up display, is going to read that variable, and if it's true, it'll draw Olaf, and if it's false, it will not draw Olaf. And that's should work right the first time, every time, right? Here we go. Boom! All right? Walk away. So, boom. Hello. Feels good. Feels good when it works right. All right. We can make it... why is this not quite the right height? Make the picture size a little bigger, maybe. There we go. It's a little, maybe too big now, but that's the idea. You know, so if you ever play a role-playing game where there's a dialogue, bloop, you know, if you want it to be in 2D, like in visual novels and things like that, like the Japanese have all these like light novel dating games, and like it displays like a portrait of a person, and you say something rude, and the face changes from, you know, you can have 5 or 6 different facial pictures, you know, sad Olaf, you know. And those can all be set using different variables, right? So if Olaf's unhappy because he's lost his head, then it could display a sad Olaf, you know. But yeah, when you walk away, it goes away. So you want to walk up and talk to somebody, pops up in a portrait of them, whatever. You can control the picture, the location the picture draws, the width of the picture, the height of the picture, whether it's zoomed in or zoomed out. You can use that technique for mini-maps, like I said. So you just have one picture for the entire world, and then you just slide it around based on where you are in the world. Let me show you that sliding thing. 400 pixels. So I slid it 50% of the way to the left, 50% up. So Olaf is now fragmented. You can have items when you're looking at, yeah. So you walk up to a trumpet and it displays a picture of a trumpet. Okay. We could tie this to time, maybe. Yeah, whatever. So you can make the thing pan if you want. So you can animate. You can have the picture sliding around if you want. You can have it zoom in and zoom out. Yeah, that's the basics. So what did we learn today? We learned the first person HUD is set by the game mode to be the default HUD on the screen. Otherwise, you can do things like you can attach and detach different HUDs and things like that. You guys should be able to see, like, you can probably make a main menu pretty easily now, maybe. Like, you know, have the first person character, have an action called main menu, right? Edit project settings, input, action mapping, main menu. When you hit escape, save. And then when they type escape, we need to set a variable called main menu, make it public so that the HUD class can see it. Compile, save, main menu defaults to off. When they press escape, it will toggle. Toggle. That's it on. All right. So we will get main menu, do a Boolean not toggle. No, fine. Do a Boolean not on it. So if the main menu is not set, not will be, if this will be false, not will make it true. So we will set main menu to be the not of the current menu. Save, compile. Then inside of first person HUD, my gosh. Okay. Mom's spaghetti. Okay. So if the main menu is set, we don't want to draw any of this stuff. Instead, my goodness. She will move all this out of the way. Gosh. Okay. Well, before we do all that, we are going to get main menu. Let's see. Ugh. Yeah. Okay. Get main menu. So we are going to get the current status of the main menu Boolean, and we are going to insert a branch before that branch and this branch. All right, so if, let's see, if main, okay, so do a branch here. So if main menu is set, we're going to draw the main menu. Otherwise, we are going to do the rest of it. So if the branch is set, let's pretend we're going to draw, let's just draw a rectangle. And let's just draw like, I don't know, yeah, black over the entire screen. And then not draw the rest of it. Sure, that'll work. Okay, so this is going to, so if we hit escape, it's just going to draw black from the top left corner to the bottom right corner. It's going to blank out the screen, and we'll just make sure that works first because we've done a lot of stuff. We've got a few minutes left in class. So there we go. Everything's working. Pull off there, and if we hit escape, damn it. It quits out of the simulation. I'm going to need a different I'm going to need a different key to get into the escape. All right. Yeah. Oh, I shouldn't have said key escape anyway. So we'll say M for the main menu. So to type the M key. There we go. And then we'll come back into first person character. And I should not be using the escape key, by the way. I should be using event, what do I call it? Main menu? So that'll work with any of my keybinds, right? So it'll work with the escape key, not when it's simulating, but and then it'll tell you which key you hit too if you want to know if it was M or escape. But we don't care. So there we go. And here. And if we hit escape, okay. If we hit M, there we go. And if we hit M again, we go back. All right. So this will work if I was not in the simulator, which is exited by hitting escape. But yeah, there you go. So that'll pull up the main menu, and I can draw other rectangles on top of it as well. Of course, it worked right the first time. So coming over to the first person HUD, so that blacks out the screen, and then on top of that, we can draw another rectangle called, I don't know, new game or something, or we can draw text or whatever. Like I said, there's a better way of doing it using widgets. But yeah, we'll just, for now, we'll just pretend this is a little button made out of red at, I don't know, 300 of size, 400, 400, and maybe we'll even show mouse. Can we do that? Mouse, unlock mouse, get mouse position. That'd be useful. So we can also have we can also grab mouse events as well. Set viewport mouse capture mode. Set it to no capture. All right. Oh, actually, it should probably be done over here. Over here. So when the main menu is up, branch. So if main menu is true, then we're going to reveal the mouse. Because normally in a first-person shooter, the mouse only appears when you hit escape, right? And so, what do we call that? Set viewport mouse capture mode. Yeah, let's try that. Let's see how that works. And so we're going to set it to no capture. If they bring up the mouse menu, it's not going to capture the mouse anymore. And then if it's false, we will... we should capture it. Let's see how that works. I haven't done that before. It should have worked, but who knows if it'll work. Play. Hit escape. Damn it. It's a second nature to hit escape. Hit M. Yeah, the mouse is now freed. Hit M again, and or maybe it wasn't. I don't know. I can see the mouse as it moves over my face. It's I don't know. There might be something else we need to do. Like I said, I haven't done that before. But that's the general idea, right? So when you bring up the main menu, it unlocks the mouse, and you can click on things. You can also set up event handlers for handling mouse clicks, so you can make a really crappy main menu that way. Like I said, there's a better way of doing it, but that's the idea. So what do you guys want to do for your homework? How do you pause the game state while in menu? There is a pause option. Where are you? Here. So there, and then pause. Set game pause to be true. Pause. Just like that. Boom. So we hit play, and I pop. Because it's paused, it's not reading events anymore. That's funny. It did pause. The permanent pause. Homework, hopefully not spaghetti. You have to do mom's spaghetti. What do you guys want? Your pick. Pick your own homework. If you like. Display a picture while walking up to an object. Okay. Seems easy enough. Maybe have a gallery. Maybe have a gallery. Like, so maybe 3 different, you know, there's like 3 different flowers or vases or something like that. You walk up to it, or 3 different people maybe in the game. You walk up and it displays some anime character. So you have like a light novel-esque interaction, something like that. How does that sound? Right, so you walk up and embarrassed Tosaka. Angry, friendly Tosaka. Right. Typical Japanese light novel kind of stuff. Are decreasing health bars just different HUDs being displayed every time they lose HP? Yeah, so you could have a variable on the player called health, right? So you just make a new variable here, bloop, called health. And health could be a float. And health could default, compile, save. Health could default to 100, let's say. And every time you take damage, health goes down. And then the first person HUD, oh my gosh, look at that. Okay, so here we could get from the first person character, get health, like that. Remember, you have to make a variable public for another blueprint to be able to grab this, right? So we're going to get the health, and then you could do something like this, where you do a little bit of algebra, and if their health is at 100, actually the algebra is really easy in that case. You just multiply the health times, I don't know, 2, and then you'll have a 200 pixel wide health bar, and then as their health goes down, when health hits 0, draw black over the entire screen, print you dead, pause the game, I don't know, permanently apparently. Does that make sense, Vacular? So what do you guys feel like? So just having the ability to talk to 3 different people, something like that? Maybe I'm making spaghetti again. I know. I'm sorry. If I was doing this from scratch, it would look a little bit different. You know what I mean? So. Nope. This will get if they're swimming or not. If I wanted, I could like turn these into variables that I could read later. Get rid of some of the. So that'll get if they're swimming. That'll get their health. This will get if main menu is set. I don't need this anymore. I don't need begin play anymore. Oh shit. Nope. I don't need you anymore. How hard is it to bring up a dialogue tree when you walk up to somebody? You can have a couple different variables like that. Like how, you know how I was setting main menu. It's just you can make it so that there's a couple different ways you can do it. You don't really know how to read a mouse click yet, though. I'd probably not do a dialogue tree yet. Maybe. So what do you guys feel like? Just walk up to 3 different objects, have it display 3 different portraits, depending on who you're walked up to. Easy. Health bar, maybe. I don't know. Health bars, dialogue. The oxygen thing's kind of cool. I don't know. Yeah, let's do 3 different portraits. So let's make a simple visual novel. And so basically, just put 3 different characters in the world. Don't use the mannequin. Get some interesting assets. And when you walk up to them, just display their portrait and maybe have different expressions. That could be kind of fun, right? If you're in front of them, oh yeah, that's a good one. You can use your vector math skills. If they're in front of you, then they smile at you. If you're behind them, they frown at you. Why are you behind me? How about that? So 6 different portraits in total. You'll have to get. Yeah. Do that. A very simple visual novel. Just trying to clean this up a little bit. Better explaining the instructions? Okay. Yeah, do this part. But for 3 different objects in the world. And jeez, look at that. Oxygen. Oxygen bar. So I can make it, if either the oxygen or health drops to 0, it'll do that. But there you go. Those are the 4 different things we did today. I'll screenshot these, put them up for you guys. Okay. All right. So that's it for today, guys. Sorry for running over, but it's kind of fun. It's kind of neat, huh? Just have things drawn on the screen, and it's a really important part of having a professional-looking game. Like, very few games just have blank HUDs. You know, there's usually some decorations of some sort on the screen. So, like I said, there's a better way of doing this, but this will get you going. This will get you going. Okay. I'd like to do grocery items with price. Sure. I'll make the directions vague enough that the grocery store will work as well. Okay. So that is it for today, guys. Have fun with it, and I will see you guys on Tuesday.